Okay, in our next section, we will be talking about solving right triangles. And, quite frankly, we'll talk about exactly what that means to solve a right triangle. Okay, but in our warm-up here, it asks us to use triangle ABC to solve these first three exercises. So we can see triangle ABC to our right. It says that if A is 8 and that B is 5, find C. Okay, so they're saying that A is 8 and B is 5. Okay, then we're going to find what is lowercase c, okay? So really, I guess our main option here, since we don't, our included angle doesn't really help us too much, I guess. So let's go ahead and use the Pythagorean theorem, right? We know that a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. So we're going to go ahead and say that 8 squared plus 5 squared equals c squared, right? And that's going to give us 64 plus 25 equals c squared. Okay, and we can sort of, I guess, combine that a little bit. And so I'm going to combine that now to 89 equals c squared. And then if I want to solve for c, I'll just take the square root of both sides. So I get that c equals radical 89. Okay, and that's our final answer here. We can't really simplify that radical, and that's all we get. Okay, for part 2, I guess it gives us a and c this time, so we don't have b. Okay, so this time it tells us that a is 60 and that c is 61, and we're supposed to find lowercase b. All right, so in this particular case, we can still do a squared plus b squared equals c squared, but this time we're going to do 60 squared plus b squared equals 61 squared. Okay, and if we go over to our calculators here, we'll get 60 times 60 gives us 60 times 60 gives us 3,600. Okay, plus b squared equals 61 times 61. Is going to give us 3,721. Okay, so by doing a little algebra here, we're going to subtract 3,600 from each side, and we'll get b squared is going to be equal to 121. And when we take the square root of both sides to isolate b, we'll get that b equals 11. Okay, so that we found our other leg there is 11. Okay, and in this last one, okay, they give us that b is 6 and c is 10. So they're saying again that this is 6 and this is 10. Okay, and they want us to find the sign of b. Okay, well, they're talking about this b right here. So the sign, remember, is just going to be that trig ratio that we learned last lesson. The sign is going to be the opposite over the hypotenuse. Right, so in this particular case, the opposite over the hypotenuse is going to be 6 over 10, which we can simplify to 3 over 5, or 0.6. Okay, so we just found the sign of b given those two side lengths. Okay, or that leg and the hypotenuse. Okay, scrolling down here a little bit, I know this warm-up is covering lots of prerequisite skills, but they will be very important. Okay, so now we're going to use the distance formula here to find the distance between 2 points. Okay, so remember we can label these x1, y1, x2, and y2, and we're going to plug these into the distance formula. So remember, the distance formula is where we take the difference of the x values and square it, and then add to that the distance of the y values and square it. Okay. Now remember, we can put the x values in the first set of parentheses and then the y values in the second set of parentheses. That's okay. So maybe I'll put the y's first. So I'll do y2 minus y1 would be 0 minus 10. And then x2 minus x1 would be 3 minus 8. Okay. Doing a little simplifying here, I get this is now the square root of negative 10 squared plus a negative 5 squared, which is going to give us, I guess, 100 plus 25. We know that the square root of 125 can be simplified a little bit more because 25 is a perfect square factor. So this is radical 25 times radical 5. And so our final answer is just 5 rad 5. Okay? pretty simple. Again, I think this is a good review for us. And so, again, in part 5, again, label these x1, y1, x2, and y2, and let's go ahead and use our distance formula to find our distance between these 2 points. So this is now going to be 6 minus a negative 2 squared plus 2 minus minus 1. So 2 minus 1 squared. Okay, continuing on, this is now going to give me 8 squared. Sorry, that's supposed to be a parentheses there. So 8 squared plus 1 squared, which is 65 plus 1. Oh, sorry, I jumped ahead of myself there. It's going to be 64 plus 1, which ends up giving me 65. So radical 65 here cannot be simplified, and that is our final answer. Okay, so again, this warm-up was a little bit of Pythagorean theorem review, distance formula review, and obviously it's going to help us with what we're doing today here with solving right triangles.